Hello everyone, happy to see you here. Welcome back to my channel. Hi, I'm Mathematics. Today we have a really interesting question. N cubed plus n squared equal to 36. We need to solve this equation for n. So if you have your solution, your answer, you can also write it in the comments below and then we will check our answer. So let's start. First of all, this 36 can be written on the left side. So let's start with it. We will have n cubed, so the same beginning, n cubed plus n squared and minus 36 equal to 0. So this is our first step. Second step, right here we have cube plus square. So right now let's try to express, we have a thumb, cube plus square, and right now let's express this 36 in that way. So we need to express this as a thumb of a cube and a square. So this 36, we can express this in a lot of ways, like for example 20 plus 16, something like that. But the best way is to express this like 27 plus 9. Okay, because 27 can be written as 3 cubed and 9 can be written as 3 squares. So then we can group cubes and squares. Okay, so right now let's express the 36 as 27 plus 9. Okay, let's do it. So we have n cubed plus n squared minus, instead of 36, let's write 27 plus 9. So we have 27 plus 9 and equal to 0. Right now let's open parentheses. Okay, let's get rid of this parentheses. So we have n cubed plus n squared minus 27 and minus 9. Of course we can do this only in one line. We don't need all of these lines, but I want to do this step by step. Okay, equal to 0. Right now, instead of this 27, we can write 3 cubed, and instead of this 9, we can write 3 squared. So as a result, we have n cubed plus n squared minus 27, 3 cubed we write, and 9 we write 3 squared. Right now, let's look at this question from another perspective. We have right here n cubed and we have right here 3 cubed, so we can easily group this, and we have n squared, we can easily group with this 3 squared. Okay, so right now let's do this step. In first parenthesis, we have n cubed minus 3 cubed, so n cubed minus 3 cubed. And in another parenthesis, we have plus n squared minus 3 squared. N squared minus 3 squared equal to 0. Right now, let's look at this question from a different angle. Right here we have difference of 2 cubes. Right here we have difference of 2 squares. So let's remember this formula from school. First formula, difference of 2 cubes. So a cubed minus b cubed. A cubed minus b cubed equal to a minus b. A minus b, and in another parenthesis, a squared plus ab and plus b squared. This is our first formula. Second formula, difference of square. I think everyone knows about this formula. This is like maybe the most popular formula. A squared minus b squared equal to a minus b times a plus b. A plus b. Really great. And right now let's apply this formula. Let's expand this expression in terms of these formulas. First of all, difference of 2 cubes. As a result, what do we have? N minus 3, in another parenthesis, n squared plus 3n and plus 9. And right here we have difference of squares. So we have plus n minus 3 according to this formula and n plus 3. Really great. Of course, equal to 0. Right now, let's look closely. What do we have? We have a lot of parentheses, but this n minus 3 and this minus 3, we can easily factor as a common because we have the same expression, yeah? We have n minus 3, yeah? And in another parenthesis, what do we have? N squared plus 3n and plus 9. And of course, plus this one, n plus 3. And plus 3. Right now we can actually get rid of these parentheses because we have all the time addition. So we can actually add something from here. So as a result we have the same beginning, n minus 3. And in another parenthesis, what do we have? N squared plus 3n plus 9 plus n plus 3. So we have n squared, yeah, n squared, plus 3n plus n, so plus 4n, and 9 plus 3 plus 12, so plus 12, yeah, equal to 0. Right now we have a product of 2 parentheses. This first parenthesis, by this one we have both brackets, but we don't actually need this one, so we can actually, I hope you understand it. We have 2 parentheses, this one and and this one. And a product of two parentheses equal to 0 when the first parenthesis is equal to 0, so n minus 3 equal to 0, or the second parenthesis is equal to 0, this one, n squared plus 4n plus 12 is equal to 0. Okay, really great. The next thing we're gonna do, we're gonna solve this expression real quick, because from here our n first is equal to 3. Yeah, this is our first real number root. We can actually underline it, so this is our first real number root. Second root, we can actually solve right here. We can actually find our second and third root with a basic method. Of course, this is up to you. I prefer a basic method of coefficients, so a equal to 1 from this quadratic equation, b equal to 4, and c equal to 12. Right now, let's plug in each of these elements into this spot. Let's find a discriminant equal to b squared minus 4ac equal to, so b squared, 4 squared, minus 4 times 1 and times 12. Really great. And let's find it. So we have 4 squared, we have 16, minus 4 times 1 times 12 equal to 48. And our discriminant is negative, minus 32. So it means, so our discriminant is negative, so it means from this branch, we will have like two complex roots. We don't have real number roots right here at this branch, so we need to find our complex root. So let's do it right now. We will have n second and n third equal to minus b plus minus square root of discriminant and all over to a. Really great. Right now let's plug in each of these elements into this spot. So we have minus b minus 4 plus minus square root of discriminant square root of minus 32 and all over to a, 2 times 1 equal to minus 4. This square root of minus 32 we can actually write as a product, so plus minus square root of 16 times 2 and times minus 1 all over 2. Okay, and right now we need to remember really interesting and really helpful property. Whenever we have square root of a times b, for example, times c, we can actually split it like square root of a times square root of b and times square root of c. So this property is extremely helpful. So right now let's apply it right here. So minus 4 plus minus. This one we're gonna split. So 6 square root of 16 times square root of 2 and times square root of minus 1 over 2. Okay, equal to minus 4 we have right here, plus minus square root of 16 equal to 4 times square root of 2, and this is our imaginary unit. This is our I times I over 2, so equal to. And the final step, let's divide this numerator by 2, so minus 4 over 2 plus minus 4 square root of 2i over 2. And right now we can actually split it by real parts, so this one equal to minus 2 and plus minus 2 square root of 2 times I. So this is our real part, this is our imaginary part. So we have two complex roots. So let's write our final answer to this question right here, for example, on the right side. So our answer, n first equal to 3, and first equal to 3, and second equal to minus 2 plus 2 square root of 2 times I, and third equal to minus 2 square root of 2 times I. So these two roots are complex roots, This one is real number root, so real number root and two complex roots. So right now, finally, let's check real quick our real number root. So let's check this n first equal to 3. So let's do the quick proof right here. Let's check it. So we have n cubed plus n squared equal to 36. From here, when we plug in this 3, we have 3 cubed plus 3 squared equal to 36. From here, we have 27 plus 9 equal to 36, 36 equal to 36. So our root is absolutely correct. And right now, few thoughts, few tricks, few moments I want to underline from here, because first of all, you have to understand that if you have 3 as the highest power, according to a fundamental theorem of algebra, we'll have like 3 roots. in total, okay? If we have n to the power 4, it means 4 roots. Yeah, this is extremely important part. If you sit in your exam, you can instantly find out how many roots do we have in our question. Like 3, it means 3 roots. 4 at the highest power, it means 4 roots. And exactly in our case, we have 3 and we have 3 roots right here. So this is our first moment I want to underline. Second moment I want to underline, because a lot of students might be thinking, okay, let's try to solve this question by inspection. Maybe n equal to 1 is the correct answer, n equal to 2, n equal to 3. And it turns into a big argument, because a lot of students might be thinking, okay, n equal to 3 is the correct answer, so I solve this question in 2 or 3 lines. It's a wrong approach, because you forget about another branch. You forget about this branch, because according to this one, you solve this question and you find you solve this question for complex roots. It is extremely important part, because it's great, of course, for you and for your teacher to solve this question completely. And this is a full solution to this question, okay? With real number roots and with the complex roots, okay? This inspection method is also great, but to check your root, okay? If you, for example, solve this question and you have like n equal to, for example, 3/2, it's hard like to get it with inspection method, but when you plug in this 3/2 with the inspection method, okay, everything is great, you check it, but solution is right here, not inspection method, so forget about it. So once more, let's look closely at this question. So here we can say it, n cubed plus n squared equal to 36. Here is our question. This is not the hard question, but if you struggle with it, if you have a problem, you can also write, you can ask about this moment in the comments below. All you need from here, this trick right here, so you need to group cubes and squares. Second moment, you need to know about these formulas, and third one, we need to solve these two branches. So it's not the hard question, but if you have a problems with it, you can also ask me in the comments. I will help you 100%. It will be really interesting to exchange information in the comments below. So this is my solution. I really hope you understand it. I really hope you learned something new. It's also really great to see your response in the comments below. It's also really great to see this question from a different perspective. Yeah, if you have your approach, you can write it, of course, from your angle. It's also really interesting to see these moments. Maybe you have something different, maybe you have a difference from my angle, from my perspective. It's also really great to see your solution. So this is my solution. Thank you for watching. Wish you all the best in your life. Take care of yourself. Have a great day. Also write your thoughts, write your response in the comments below. It will be really interesting to exchange information, and see you in the next videos. Have a great day and take care of yourself.